Hello everyone. So I wanted to just talk a little bit about Upwork architecture, and with a focus on kind of what we're doing on the front end with PHP. And so at Upwork, one of the things that's kind of important for me to clarify is that our back end, where a lot of business logic isn't in PHP. So PHP is kind of only on our presentation tier. And then we, obviously we have client-side code. So whenever I talk about front-end or talk about presentation tier, I'm talking about client-side on the browser, but also our PHP layer. Good, okay. There we go. So just to kind of introduction to my talk here. It's not on there. Okay. So I just kind of want to talk about what our legacy stack was, the reasons that we wanted to change away from that, and the changes that we wanted to make, and then talk a little bit about what our new stack looks like, and then kind of planned works for the future. So our legacy stack was kind of a two-tiered architecture with PHP doing the presentation tier and a Perl RPC layer on the back end. The communication was something proprietary. We wrote it ourselves. It was over HTTP, but not using any kind of REST or any other like standard technology. So we would just do kind of posts to localhost, and we'd get responses back from those functions. And then what was happening is that both layers would get deployed to our app servers, and so we had a cluster of app servers. Each app server would run both the back end and the front end code, and then the calls were made to localhost. On the browser side, we were using jQuery with some custom CSS. And the PHP layer was in Zen framework, Zen 1. So this was kind of what our legacy stack looked like. There's still some of it there, but we're trying to get rid of it. And moving to the new stack. So some of the problems that we were having, we were releasing infrequently. We would only release weekly for a while, and then we started doing 3-time-a-week releases. Oftentimes we found that releases would get blocked. We wouldn't be able to release because some part of the code wouldn't work, and so that would delay other teams. So one team was trying to release a feature, but another team had a bug in their code, and so we couldn't release. And then we also had kind of an aging code base. We were using some legacy we were using Zen 1, we wanted to switch to a newer PHP framework, and that was difficult to do. So for these reasons, we wanted to switch to a new new architecture. So when we had a new architecture, we wanted to do several things. One of the most important things that we wanted to do was to isolate risk. We wanted features from one team not to affect another team. Teams have different amounts of risk tolerance. So we have, let's say we have our payment processing system, and our payment processing system is obviously not very risk tolerant. They want to test everything thoroughly before they release. But we have other things on the site that we want to release, much more frequently, and we want to experiment with them. We want to A/B test a lot, and so they're a little bit more open to taking risks. And so we wanted to be able to separate these risks out so that the billing system would, could be very conservative in the risks that they took, but the other sections of the site that were tolerant to risk could release more frequently. So we wanted the teams still to work independently, test independently, and then deploy independently. And then we also wanted to allow for some automated release systems. We wanted, like push button kind of deployments. We also wanted to be able to do some of these like fancy deployment techniques, blue-green, where we would bring up a new cluster and then start sending traffic to our new cluster, and canary releases. And these were difficult to do in our data center with dedicated hardware. So the first part of the architecture that we replaced was the back end. We started working on replacing the Perl layer with a microservices architecture, and internally we call it Agora. So it's in Java. It uses some of the Netflix open source tools, Hystrix, which I'll actually talk about a little bit more later when I get to our PHP version of it, and then Eureka for service discovery. And we deploy everything in AWS. So that helped with some scaling and also the deployment patterns that I had spoken about. So then we wanted to extend the concept of microservices to the front end. So we wanted to split up our PHP and our client-side code to be able to kind of mimic that microservices architecture, have independent applications that run. And what we found is that we had a few challenges that we wanted to solve when we did this. One of the problems that we had was dealing with routing, and microservices is not really an issue that you have. Each service runs on its, kind of runs at the root. It's not an issue. But when we start talking about the front end, you want to route, /A to one application and /B to another. So that was a problem that we wanted to solve. The navigation and other cross-cutting concerns became an issue. How do you display navigation across a set of front-end pages when they're not sharing code? And then finally was kind of the issues with logging visibility. When something goes wrong, how do you find who's responsible and track down problems? So the stack that we ended up settling on, at least from languages kind of standpoint, we stuck with PHP. We decided to go with Symfony 2. The decision for Symfony 2 versus Zen 2 turned out to be, so we had some internal discussions. I don't know that there's anything particularly important there. We ultimately settled on Symfony 2. On the front end, we decided, on the client side, we decided to go on with AngularJS, and write a component library on top of AngularJS and Bootstrap. So we're using Symfony 2. We have a lot of custom bundles, and that's the way that we share PHP code now among different front-end units. And everything is distributed with Composer and an internal Composer repository which runs Satis. And then we have a component library which we write, and we package those up. It's kind of similar to the way, let's say, Bootstrap or others would distribute their packages. It runs on a fixed URL. Everybody inside the company refers to it. And then one of the important things that I mentioned specifically here is the navigation service. I think that it was really important for us in order to be able to do this kind of microservices thing on the front end. One of the problems that we had was that the decision on how to, which tabs to display, which links to display to the user was something that there were decisions that we were making on the front end in PHP. And we couldn't have every team with every section of the site making those, having that shared code. So we moved that to the back end as a Java service, following the Agora pattern that I mentioned earlier. And that's a theme that I think is going to happen more on the front end. We're going to be moving things that we used to have in PHP into Java, into services. So one of the first problems that we started to encounter when we actually started launching with Agora, the backend, even before we did the work on PHP, was how do we talk to Agora? Agora services are RESTful API, they're web services, but we wanted to have a standard way of building libraries. And what Netflix was doing was they had a tool called Hystrix, which implements a circuit breaker and implements a command pattern, and also has fallbacks. So you write I'll show an example, but you write a command, and then you also say what happens, what the code should do when it fails. So we wrote Hystrix, which is our kind of port of the Netflix Hystrix library, and we also open sourced it. So you can visit the GitHub page, and you can use it in your projects as well. And we're hoping to open source other portions of our stack as we make them generic enough for other projects. So here's kind of an example, and sorry, it might be a little hard to read, but it's a direct copy and paste from our GitHub page, so you can take a look at it there. You implement you extend an abstract command, and then the run is whatever code you want to run, and that would be where you would make network calls with whatever HTTP client or whatever you want in that section. And when those and if you end up with a lot of failures there, the circuit breaker opens, and so you stop making requests to your backend service. So then once the service is back up, it closes the circuit breaker again and starts making requests. The details of it are you can read it in the README, and it's quite configurable as to what your tolerance of errors are. When you go to use the command, it's pretty simple. You create an instance of the command and you run it. The other issue that we were trying to solve was around visibility, which I mentioned earlier. The problems with how do we find errors. We are obsessed with Grafite at the company. We try to log everything into Grafite and StatsD as an interface for that. So we have a metrics bundle that runs in Symfony. It provides timing for all the actions whenever there's a request. I think it also will log error rates and things like that into Grafite as well, so we can monitor those in a nice visual way. And then developers can also time whatever they want. If you have some custom section of code that you want to monitor its timing, it might have performance problems, you can put that into Grafite as well. And then we use the ELK stack. I don't know if you're not familiar with it. It provides some centralized logging and searching mechanisms. Logstash reads the files, it puts it into Elasticsearch, and then Kibana is a front-end tool for it. So that let us aggregate our logs into a central location that we can search, we can look for errors, and then identify owners and debug from there. One of the other important things to mention about ELK is that it also gives visibility to developers to logs, so that they can debug issues when you don't want to necessarily give them, access to production systems. You don't want them to be able to go in there and tail logs. And also, when you have a cluster of systems, it's not a very efficient way of finding errors anyway. So testing. One of the things that we really wanted to make sure that we have quite a bit of when we started our new stack is to be able to have good testing infrastructure. We wanted to be able to not to rely on manual QA, but to really improve our unit testing and automated testing systems. So we have, so we're using PHP unit for PHP, pretty standard there. We have a fixture system for dealing with dependencies, So you can run a real request, and we record the results of that, and then you can use it in testing after that. We are trying to use mostly the terminology. I think Google might have mentioned it in one of their books, how Google tests software, that they've been avoiding the use of terms like unit, integration, functional testing, because they start to lead to confusion. And if you've ever been a large enough organization and you start talking about these terms with people, you'll notice very quickly that what one person's calling an integration test, another one's calling a unit test, another person's calling a functional test, or end-to-end tests. And so all these terms start to become kind of confused. And so we've been trying to stick with just the small, medium, large naming. So on JavaScript we use Karma and Mocha for writing our small tests, and then we have Protractor, which has a Selenium WebDriver library built into it for testing Angular applications for our medium tests. Then we have part of our CI system. We're running Jenkins. Each time there's a commit to one of the projects, Jenkins runs a series of Jenkins jobs. The first one builds a Docker image of the project, and then we run the tests there. So we run the PHP tests, the JavaScript tests, etc. And when those all pass, right now we push the Docker image to Docker Hub, but we don't do anything with it after that. So hopefully soon we'll do more with that, and I'll talk about that when I get to kind of future work that we're doing. Okay, sorry, so I had added a slide, but I think I sent my presentation before I did. So I wanted to talk just a minute about routing, which was another one of the challenges that I had mentioned. So currently the way that we handle our routing is that we have a front-end Nginx load balancer that has the routing information. It has which route it should, for each of the routes, it has an upstream which points to an ELB, which points to the stack that we're running. So it's not a very flexible system. It requires a lot of manual work, and so one of the things that we want to do there is to use console, which I mentioned for configuration here, but to use console for routing as well. So console provides like service discovery, so each of the applications will act as the same way as a service would, and then we use the key value store there to actually to link those up, to link a route up with the app service that it's going to point to, and that allows us to remove the ELBs. But it also we use console template to generate an Nginx config. So every time there's a change in console template will run and regenerate an Nginx config, which then takes effect. So that's how we're going to try to solve the routing issue. I think there's a couple of other routing related problems that we haven't quite found solutions for, like how these sections of the application point to URLs from one another. And hopefully we'll come up with a solution for that, and we can share it when we do. At this point, they're just kind of hard-coded URLs. So as far as future work that we want to do, we're really exploring Docker. I hope to get it into production fairly soon. So that after the Jenkins jobs runs and we push it to Docker Hub, you can use that Docker image as an artifact that moves from development to staging and then into production. So you're testing the same artifact as you deploy into production. And that kind of brings me to our continuous delivery and continuous integration pipelines, which is the other area of improvement for us. We want to be able to reduce the time from when code is written to when we can have it in production. And I think having a good testing system and good continuous integration is going to be essential there. And then, again, like I mentioned, a lot of work with Docker. One of the things that has to happen there is the kind of dynamic configuration in order for a Docker image, the same Docker image, to make it from development into production. You can't have hard-coded environment variables or other references to, let's say, dev or staging or databases. So all of those have to become dynamic, and console's very likely going to be the tool that we use for that. So I think that's all I have, and I'm open to questions. Sarah.
Hi, thank you for your speech. And I want to ask why you choose Grafite. Maybe you have a comparison with New Relic, for example, that is equal to this.
Sure. So we actually do use New Relic as well, and it gives us some different visibility. One of the things that we found is the New Relic does a lot of it's a good overview of the applications. There's not but it does a lot of sampling and other things that Grafite doesn't do. Grafite's fully within our control. It doesn't do any of the New Relic magic, let's say. So sometimes when we were trying to interpret New Relic data, we found that we weren't quite sure how they were interpreting our application, whereas with Grafite in our own implementation, we have full control of that data.
So main reason is that Grafite is more simpler and more useful in your cases.
Yeah. We find it simpler. We find that we have full visibility into that data. When you're tracking down a problem, one of the when you're looking at data, it sometimes becomes a problem with if you don't really trust the data that you get. And not that I'm saying you can't trust New Relic, but if you don't know how to interpret it properly, or there are issues with the data, then tracking down problems becomes even more difficult. And with Grafite, we can have all sorts of different counters within the system. We can have precise number of times things were hit, error rates, and things of that sort. And we can time. New Relic will let you add timers to custom functions, but if you just want to start and stop it, it doesn't quite work for us to do that.
And do you use Grafite for some triggers by events? Has it such ability? So, for example, New Relic has triggers you can put it to send emails when there are a lot of requests and some overloads or something else.
Right. So Grafite is only kind of a data store with visualization. We have a system that takes in some. It's a monitoring system, and you'll let's say tell it a metric in Grafite to watch, and if you consider that to be critical or just a warning, and then based on that, this monitoring system will make alerts.
I see. Thank you for your answers.
Yeah, absolutely. Thank you for the questions.
I wish you to mention the tracing system we integrated in our PHP and Zipkin. Can you tell some words about that?
That's good. I probably should have mentioned tracing and Zipkin. So Zipkin's whose open source? I don't know whose open source tool it is. It's was it Twitter? Twitter? Yeah. So it's an open source tool. It lets you kind of see waterfall charts of a request trace that happens in a distributed system. So from the point that a request comes into the front end, we trace it through all the series of various microservices that they get called, and we get timing data for it. So you can, if a request is being slow, you can look at the Zipkin trace and identify where in the trace you were hitting problems. If it's a particular service that's a problem, and then you can debug it from there.
More questions?
I'll take them in Russian too. I have translators.
Yes, we can translate it if you would like. You will get gifts from Upwork. Yeah.
Hi. In our case, our architects made a decision to choose a Scala for front-end, no, for web part. Why do you prefer PHP? Actually, do you
consider?
Do you consider Scala or PHP?
So I don't personally have a ton of experience with Scala. I started working with it a little bit, and it's actually a language I really like. I think when I first started learning it, I had joked with somebody that I haven't liked the language since I learned the QBasic. Didn't require line numbers anymore, so Scala finally impressed me. It's a really cool language, and we contemplated it, especially on the back end, as where I said Java. At the time, especially, it was difficult to find Scala developers. There weren't a lot of people learning it, so we thought we could move a lot quicker with Java. And I think the thinking was very similar on PHP. We had a large number of developers who are already programming in PHP, and we had a lot of experience with it. Picking a new technology, like a completely new language, would have been much more painful to implement.
Hi.
One more question there.
Can I?
Oh, here? Okay, sorry.
Thanks a lot for your talk. It's pretty insightful. I have one question from three, and they're about cluster management, scheduling, and orchestration of your Docker containers. What tools do you use, and do you use them at all?
I'm sorry, orchestration,
scheduling and cluster management, maybe something like Kubernetes or Nomad or...
regarding Docker?
Yeah.
So currently we're not using Docker in production. So we don't schedule containers in production. And I don't know. I think there's a couple of different ways we can go with that. I've noticed that most of the tools around Docker, even like Amazon's tools or Kubernetes, will let you, tell it that you want to run, 20 containers, and it'll run them. But they don't seem to have a lot of infrastructure in place to auto scale or to monitor your system. So I'm not sure. It's something that we'll have to research as we get closer to placing Docker in production. Hopefully there's more developments that happen there. And if you have any suggestions, I'd be glad to talk to you about it.
Hi, Seb. Once again. I'm here. You see? Seb, look, probably this is not a matter of PHP and UI team, but at least some problems comes from the jobs side. To look after all of this stuff, I wonder, is there a solution to move some resource utilization into Grafite? Should it be done by those layers, or should it be provided from other applications or from our components? Did you get my question?
I'm not quite sure.
Okay.
But it's starting to feel like a company meeting in here, not
Yes,
not a presentation. So soon I'm going to be asked for deadlines and when things are going to get done.
No. I'm speaking basically just from my I don't know, from problems which we met on staging. Sorry for that.
Yes. So we're working on there's a monitoring system that I mentioned earlier that monitors graphite. It's kind of a work in progress.
How to move resource utilization monitoring into all of this stuff, graphite and what else? Because we need to watch for CPU usage, for disk and space somehow through I guess through these tools or.
Yes, so we have all of them are running. The system's all running in AWS currently. There's CloudWatch, and you can set up CloudWatch alerts. And then our monitoring system, whenever there's a CloudWatch alert, sends out. If it's critical, it'll send out PagerDuty alerts to people who are supposed to be watching the system. It's still kind of a work in progress.
So just from AWS, we're going to look after that, right? Nothing else?
Yeah, and then soon we'll have like an Nagios agent that runs on the box and monitors some other stats, and you can do the same thing there to watch. I think the problem's going to become much more interesting when we go to Docker and watching like resource utilization of containers, which I think are going to be a little different than what we're used to seeing with even with like virtual machines like AWS. I think we're going to start seeing kind of different stats to monitor on containers.
What I'm asking you probably as product architect at our team, at our company at least, to provide me a single place to watch for all of this stuff, for resource utilization, for all of these business metrics being provided by team. So I would like to have something configurable for all of this stuff and not switch to various windows for all of this information. Is it possible?
Sure, everything's possible. It's just a matter of resources and time.
This gives me a hope. Thank you.
One more question, I guess. Таня, тут впереди желающие.
Thank you for your speech. Short question, maybe out of topic. It's about front-end. Where do you store CSS and JavaScript files? It's Amazon S3, and in case if it's yes, how do you deploy this CSS, and do you use some minimizations, file combinations, and how do you do that?
Yes, so our global components library, which contains most of our JavaScript and CSS, it lives in its own Git repository, has a build process, which minimizes it, combines files, does those sorts of things. When that's done running, we do push it to S3 in a bucket, and we have our CDN runs in front of S3 to edge cache them, and we semantically version the library. So whenever we do a new release, we version it so that we can have long-living caches. So the browser should cache it for a year. So should the edge of our CDN edges, and then next time we have changes, we upload the new file, and new applications will start requesting the new version. Does that answer your question?
Yeah, cases.
I think the very last question there.
Hello. Did you consider using syslog with database storage for logging? And why did you build the stack for logging you described?
Okay, so we didn't build the stack. I mean, it's an open source system. You can go to Logstash and you can run it yourself as well. And I think it will support syslog, and you can actually take syslog messages and send them into Logstash as well. Logstash uses the Elasticsearch, which gives you pretty good searching capabilities and pretty scalable search. So if we put it into, I don't know, a relational database, then we'd have to somehow solve the searching and the visualization problem ourselves.
So it's just first choice. You didn't compare it to syslog.
Well, I mean, you can use syslog-d. I mean, applications that log to syslog can go into Logstash. I don't think that the two are mutually exclusive. So if you have tools on the servers that run and are logging to syslog, you can take the Logstash agent can take the syslog data and put it into Elasticsearch.
Thank you.
Thank you.
Thank you.
Thank you very much, Seb.